Hi students, welcome to my physics classes. Today we will discuss kinematics 1D motion. I will start with the definition of kinematics. Coming to definition, kinematic deals with study of motion of objects without considering the causes of motion. Means kinematic deals with just motion of the objects, how objects are moving. It deals, but these do not teach what is the reason. Causes means reason. What is the reason behind the body is involved in motion? That is nothing but kinematics. To analyze kinematics, there are some important terms. Today I will cover some terms. Actually, distance, displacement, speed, velocity, acceleration, these are all kinematic terms. So you should know to understand 1D motion or 2D motion. Today I will cover distance and displacement and some applications. Distance denoted by letter S. On the other hand, I will take displacement. Denoted by the letter S bar. If I define distance, the actual path covered by a particle in a unit time is called distance. The actual path covered by a particle in a given time is called distance. And coming to displacement, the shortest distance between initial and final positions. The shortest distance between initial and final positions is known as displacement. I will explain in detail what is distance and what is displacement. The actual path covered by a particle in a unit time is nothing but distance. Imagine the situation. There is a boy. A boy want to reach a school. Suppose this is a school building. He want to reach to school from the home. Started his journey at this position at a home. There are so many paths. He can able to move this way. This is one of the path. Finally, he can reach, and he can able to move this way. This is another way. He can reach to school. This is way 1. This is way 2. There are some another way. This is way 3. If you observe, there are different paths are there. Paths are ways. He can able to reach to school. Here, the main important thing you should observe, there are turnings. There is a turning. It is not a straight path. Among all paths, there are turnings. Means each turning gives the change in direction. Here, the direction is not constant. Suppose he is moving this way. This is the direction. He is taking turn. So direction not remain same. Different directions are there. But suppose he select the path 1, so that this is the actual path. actual path. So this become distance S. Suppose he select path 2, this is the actual path, and this will become distance. What? Why? Because it is a actual path. If we select path 3, this is also actual path, distance. Suppose path 1 given as 2 km and path 2 1.5 km, path 3 it may be some 3 kilometers. If you observe, it has magnitude. Magnitude is a number. 2 km is a number, 3 km is a number, 1.5 km is a number. So distance is a scalar quantity. Coming to scalar, scalar is a physical quantity. It should have only magnitude, no particular direction. Particular direction is not there. If you observe among any path, there is no particular direction. So that distance is considered to be scalar quantity. It is a scalar. Distance is a scalar. Now coming to displacement, shortest distance between initial and final positions. I will take the same example. A boy started at point A and he want to reach to school. Path 1, this is path 2, path 1, path 2, again zigzag path means so many turnings are there, actual path, these 1 and 2 paths gives actual path nothing but distance. So whenever you drawn a vector between initial and final positions, so now this become displacement. It denotes displacement. Why? Because there is a particular direction is there. Suppose path 1 is 2 km and path 2 is 2.5 km and path 3 is 0.5 km. This is shortcut, nothing but shortcut. So he can able to reach quickly to the school by taking path 3. If you observe, the path 3 has magnitude number 0.5 km and path 3 has a particular direction. It has magnitude and direction, so that it become vector quantity. Vector is a physical quantity. It should have both magnitude and direction. So that displacement is nothing but vector. Displacement is a vector or vector quantity. I hope all of you understand. Now we will discuss some applications. There are some important comparisons between distance and displacement. We will discuss the first point. Displacement is always less than or equals to distance. Displacement S bar is always less than or equal to distance S. Very important statements. Suppose any particle started at point A and traveled to point B. A to B, say 100 km distance. A to B. As it is a straight path, we are discussing 1D motion. particle start at point A and stops at point B. So in this situation, distance is equal to displacement, or displacement is equal to distance S. Why? Because A to B, shortest distance between initial and final position, displacement satisfied. Actual path covered by a particle, distance satisfied, so that both are same. Situation 1. If you observe situation 2, A to B 100 kilometer and particle taking U-turn and coming to point C, it traveled 50 kilometer backward. 50 kilometer backward. Now if you observe here, the distance S is equal to actual path covered by a particle A to B 100 kilometer, B to C 50 kilometer, means actual path is 100 plus 50, 150 kilometers. Now coming to displacement, shortest distance between initial and final position. This is initial position and C is the final position. Initial to final position 100 kilometer and he returned 50 kilometers. So 100 minus 50, you have to subtract 50. Initial to final position, only S bar is equal to 50 kilometer. If you observe carefully, S bar is a 50 kilometer, S is a 150 kilometer. So S bar is a displacement which is lesser than S. Mathematically, it can be represented as displacement is less than distance. So from these two examples, we can understand displacement is always less than or equals to distance. Next, we will do some more examples. And also we can observe here, for a moving particle, distance can never decrease. If you observe, it is moving, distance is never decreased, it is still increasing. But displacement can able to decrease, and displacement is decreases here. Understand? And another important statement, displacement may be zero, negative may be zero. If you observe, suppose the particle is coming from C to D, now it has covered, for example, another 100 kilometer. Now what happened? This is the initial position, this is the final position. 100, 50, 100, total 250 kilometer distance. Distance increases every time. Each time for a moving object's distance remains going to be increases, but coming to displacement, it may be zero or negative. But distance cannot be zero, still going to be increases. Now if you observe displacement, this is initial position, this is final position. 100, 50 plus 100, 150, 100, 150. So here 100 is considered to be that direction, Cartesian coordinate system, considered to be positive, and 50 plus 100, that is considered to be 150 kilometer negative direction. So which one is greater? Negative direction. This is greater. 150 minus 100 minus 150 plus 100, that equal to minus 50 is the answer. So displacement may be negative or zero. Suppose particle started at point A, again it is coming to the point A only, then what happened? Displacement is just zero.